All right, we are looking at power of a power property. Just for a quick review, we reviewed our product law. This one here is our product law. If we have the same base and we're multiplying them together, we can add our exponents. So here, x to the power of 11. Here we had our quotient law. X to the power of 10 divided by x to the power of 7, we can subtract our exponents. So 10 minus 7 gave us x to the power of 3. So that's just a quick review of the product law and the quotient law. Next, we are looking at, all right, so our next law then is called the power of a power law. And to solve an equation with more than one exponent associated with only one base, so for example, if you had 5 to the power of 4 to the power of 3, you can use the exponent on the outside of the brackets to tell us how many times to write the expression inside the brackets. So if we have 5 to the power of 4 to the power of 3, in factored form, we can write that as 5 to the power of 4 times 5 to the power of 4 times 5 to the power of 4. Now we would use our product law where we would add our exponents. So 4 plus 4 plus 4, that gives me 5 to the power of 12. But notice, if you multiply 4 times 3, you would also get 12. All right, so the power of a power law, if you have a base to a power and then it's to another power, we can multiply the exponents. So let's take a look at our first example. We have 12 to the power of 4 to the power of 5. So it's a power of a power. So we can multiply our exponents. So it becomes 12 to the power of 4 times 5, which will give me 12 to the power of 20. All right, so power of a power law, you would multiply your exponents. Let's take a look at our next example. We have 8 to the power of negative 3 to the power of 7 to the power of 2. All right, so we have the same base though, so we can multiply the exponents. So negative 3 times 7 times 2. That gives me 8 to the power of negative 42. When I multiply all those together, I get 8 to the power of negative 42. Let's look at our next example. 5 to the power of 2 times 6 to the power of 3, and everything inside the brackets is to the power of 4. All right, so writing that out, to simplify this, we would have 5 to the power of 2 times 4, and then we would have 6 to the power of 3 times 4. All right, so that gives me 5 to the power of 8 and times 6 to the power of 12. Okay, we have another example here. We have 3 to the power of 4, a squared, b cubed. All of that is in brackets to the power of 5. So we would use our power of a power law for everything inside the brackets. So that's going to become 3 to the power of 4 times 5. A to the power of 2 times 5. And b to the power of 3 times 5. All right, so continue to simplify. So that gives me 3 to the power of 20. A to the power of 10. And b to the power of 15. This next example, we have x to the power of 2, y to the power of 3. They're in brackets, they're to the power of 5. So same thing here, power of a power. We would get x to the power of 2 times 5 and we would have y to the power of 3 times 5. So that gives me x to the power of 10 and y to the power of 15. All right, just showing that step here. It is still important to show your steps so you don't make mistakes, and you can always go back and see if you do make a mistake, you can see where you made the mistake. Okay, so next example, we have 3, and there's no exponent shown here, but always assume there's an exponent of 1. So 3 to the power of 1, so 1 times 7, because everything is inside the brackets. So it would be 3 to the power of 1 times 7, and then we have x to the power of 3 times 7. So that gives me 3 to the power of 7 times x to the power of 21. All right, our last example on this slide is we have a fraction, but all of it is included in the brackets, and it's to the power of 7. So the numerator and denominator, we would apply this a power of 7. Okay, so we would get here 3 to the power, so 1 times 7, so 3 to the power of 7. A, 2 times 7, so a to the power of 14. Then we have b, 3 times 7, which is 21. And then for our denominator, we would have to do 4 times 7, which would give me c to the power of 28. And we can't simplify further. We could do 3 to the power of 7, but we'll leave everything in exponential form. So that would be the answer left in exponential form. The last slide here is using all the rules for exponents to write each answer in simplest exponential form. So here we have, resume the recording. Okay, so in this question, let's use our power of a power law first. So we get x to the power of 2 times 3, which is 6, and we have x to the power of 5 times 3, which is 15. All right, but notice we can now use our product law as well, because we have the same base as x times x, so therefore we can add our exponents, right? So we would add our exponents now, 6 plus 15, which would give me 21. All right, so this particular example, we were able to apply the power of a power law as well as the product law. All right, let's take a look at our next example. We have here a to the power of 4 times a squared and then divided by a cubed. So in this particular example, we can apply the product law as well as the quotient law. So first, we shall use our product law. So we would get a 4 plus 2, which is a to the power of 6. And then we would divide by a to the power of 3. So we would subtract our exponents now, 6 minus 3, which would give me a to the power of 3. And our last example here, we have, again, it's a division, but all of it is in brackets. So therefore, this exponent of 7 applies to everything in the brackets. So you can choose here to do your power of a power law first, or you can do what's in the brackets first. You can use your quotient law first and then apply that 7. So let's reduce what we have, let's simplify what we have in the brackets first. So we'll use our quotient law. So we have 2 minus 3, that would give me -1. And then here we have b, 3 minus 6 would give me -3. And then c, we have 6 minus 8, which gives me -2. And then all of that is to the power of 7. Don't forget that it's all to the power of 7. All right, so now we can apply this 7. We can use our power of a power law. So that would give me a to the power of negative 7. Negative 1 times 7 gives me negative 7. And then b, negative 3 times 7, which will be negative 21. And then c, negative 2 times 7, which would be negative 14. Now you could have done it the other way as well, where you did the power of a power law first, so multiply all the exponents, and then use a quotient law after. You would still end up with the same answer.